The purpose of this video is to introduce you to Java's 4 primitive integer types. First of all, let's talk about primitive. Primitive means that values are not stored as memory addresses as they are in Python, but they are stored directly as bit patterns under the variable's name. So to get started here, let's open JShell. Now the smallest of these 4 types is the byte, and we had some discussion of it in the last video. And here's one thing we did. We made a byte be 1, and then we said while that byte is greater than 0, let's go ahead and go B++. Okay, the plus operator increments the byte, and it increments as if it were an unsigned integer. And you'll see that B is now negative 128. And we know what happened. We went all the way up to 127, which is 7 ones in the bit pattern. We added 1 to that, and we got 1 followed by 7 zeros. Now you take those 7 zeros, you know it's negative. You take those 7 zeros, you flip them, and you get 7 ones. You add 1, and you get 128, and it's negative 128. So that was the result of that. Now, the second primitive integer type is short. And we're going to do exactly the same thing here. We're going to say while s is greater than 0, s++. Let's see what we can learn about this thing. That's a familiar looking number. To anybody who is an aficionado of computing, one knows that that is negative 2 to the 15th power. Okay, so this was negative 2 to the 8th. This is negative 2 to the 15th. So what's happening here is that we're going all the way up to 32767 and then back down again. A short is a 2-byte signed integer. Okay, so a byte is a 1-byte signed integer, and a short is a 2-byte signed integer. It is stored in 2's complement notation in exactly the same fashion that a byte is stored. Now, short and byte are used a little less commonly than the main workhorse type, which is int. Int is a 4-bit byte signed integer, and here let's check that out. Let's make an int, and we'll set it equal to 1. Well, I is greater than 0, I++. That took a fraction of a second. And you can see that's negative 2 to the 31st power. So we have 32 bits or 4 bytes in an integer. Now, while we're in here, we'll talk about arithmetic and equality and other issues as well. For arithmetic, integers have plus, minus, times, and divide. Okay, so those work, plus, minus, and times work as usual. So let's say I say int x equals 5, int y equals negative 13, and I go x plus y. No surprise. No surprise. No surprise there. Now, here's something that might give you a surprise. Integers by default, do integer division. They truncate toward 0. Okay, so that's something you need to be aware of. Integers do integer division. It works just like this. In Python, there's integer division. In Java, you just need a single slash. I don't think I don't think Java understands 2 slashes. Oh, it does. That's something else. Oh, I see what's happened here. Double slash is a comment. So that comment got ignored, and we just got the value x back again. Now, one thing you should know is if I do a short s equals 4, uh-oh, what happened here? Now, you would expect that this would be 8. But what happens, and this is kind of an odd thing, byte and short, in the presence of arithmetic, get promoted to int. Okay, so they automatically get changed to integers. So you have to watch out for that. Now there's one other type, and that is the long type. Now if I did the while loop, it would take forever. But I will show you this just so you know. There's a constant in Java called long.max_value. There's the maximum value for a long. And you can imagine that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 9.22 times 10 to the 18th. Yeah, it might take a really long time for us to find our way there and for a long to donut out. So that's why I'm going to elect not to do that. So we have byte, which is 8 bits short, long, and int. And the most common whole number type in Java is int. I would say that ints are maximally efficient, and 99% of the time when you want an integer type, you're going to use a plain old ordinary 32-bit integer. Now let's talk about assignment just a little bit. Hey, let's try to assign something that's out of range. I'm not allowed to do that. I get yelled at. This would be a compiler error. If I were to do this in a program, I would get a compile time error. However, I can do this. Java does have casting. Byte b equals byte 675. B is minus 93. Yike. I wonder how that happened. Now, I'll leave this up to you. But if you write down the bit pattern for 675 and you chop off the last 8 and you look at it as a 2's complement integer, you might be able to figure out exactly what did happen there. So this right here is called downcasting. Downcasting can leave you downcast. Now, if you do something like this, B is going to happily be 9. But when you cast, you're responsible. The doctrine of caveat emptor applies here. That would be let the buyer beware. So if you do something imprudent with casting, it's entirely possible that you will produce a pernicious kind of error. It will not be a compiler error. The compiler error says, oh, he knows what he's doing. I'm going to go ahead and do this. Instead, it's going to be a runtime error. And that runtime error could cause a logic error, which might be hard to ferret out of a program. So you need to be careful when you're casting. In general, you can do things like this. See, b is 9, int x equals b. I'm moving from a small house, it's a 1-byte house, to a 4-byte house. So all my furniture, hopefully, in principle, should fit pretty nicely. Upcasting will occur without comment. And by upcasting, I mean you can go ahead and say int, or you can say long. Hey, I can even cast this byte. And x will be 5. Okay, so it is easy to move from a small house to a big house. That's called upcasting. That will occur without comment. If you inadvertently downcast, well, if you downcast, you can have an error. Now, if you are downcasting, you must do so explicitly. As we saw in this case, here, let's just go right to the edge. It's not going to allow me to do that. And it's even going to think of 128 as being an integer. And I'm in trouble. But if I go byte b equals 127, I'm fine. Okay. But if I go b plus plus, I'm now at negative 128. Okay. So you need to be prudent about choosing the right size. But I will tell you that a very common use of integers is for indices walking through collections like list. Java has a list type. You will learn about that. The integer is the correct tool. Usually you reserve long for special situations like long identifiers, things like that. But in general, integer is the workhorse type in your code. Now, so we summarize here. We have 4 types. We have byte, which is the smallest and short. Then we have integer, which is 4 bytes. That's the most common. Then we have long, which is 8 bytes. Okay, and that will go from 2 to the negative 63 all the way up to 2 to the 63 minus 1, which is a humongous number. Let's do a quick example of just using integer types in code. So I'm going to go ahead and exit this session. And I'm just going to int examples. Okay. And I'm just going to put a main in here because we're just going to talk about some simple procedures. Okay, and so I now have myself a little Java program here. Okay. So for any of these types, declaring a variable that type is simple. You just go int, and then the name you want to give it, then the value, like so. Okay, just as print in Python works, you can print out number like that. And you saw me use this. Printf, formatted printing. You can do this as well. And now let's go ahead and run this program. Okay. Yeah, yep, you can see what it looks like. Here, let's go ahead and deliberately downcast, but do so implicitly. So I'm going to say byte B is equal to 675. All right. And I'm just going to leave it at that. And you can see putting an illegal value into a byte is a compile time error. This program did not compile. So the .class file that we have is the old version. It did not get overwritten. But you can do this if you wish. And I'm going to go ahead and do this. Equals. Oh, wrong program. And you'll see that the expected thing has occurred. So these are the 4 primitive types. Now, one thing I should note for you is double equals. While we're in here, let's talk about double equals and relational operators on integer types. They work exactly as you expect them to. So if I say int caps is equal to 5, and I say system.out, okay. This should print true. Let's go ahead and run it. You'll see that prints true. Oh, let's have a little fun here. And you can guess what I'm going to do here. All right. I wonder what's going to happen here. Let's find out. No error from the compiler. Ooh, that came up as true. Now here's a thing you need to know about primitive types. Primitive types store their values directly. This is in contrast to Python. When you make an integer in Python, Python stores the memory address where that integer is stored. Java, in this primitive scheme, is not doing that. This is storing directly. X is pointing at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 19, 20, 21, 22, 23, 24, 25, 26, 29, 30, 31, 32. It's pointing directly at that bit pattern. So number you can think of as being a box, okay? And it holds 32 bits. And those 32 bits are stored exactly. So a memory address is not stored here. The actual value is stored. So when you use double equals in between two primitives, what you're asking is, do those two variables store that same value? It's checking for the equality of the bit pattern. And even here, you can see that C, let's look at what C is pointing at. C is storing this. It's actually equal to this. 1, 2, 3, 4, 5, 6, 7, 8. And it's just blowing off the leading zeros and checking to see if there's the same pattern of ones lurking inside. And there is. So therefore, these two things are seen as being equal. You also have the relational operators on numbers. And let's remember them from Python. Greater than, less than or equal to, greater than or equal to. is equal to, not equal to. These are utterly unsurprising. They behave exactly as you expect them to. They all return a Boolean, which is a true or false. Yes, Java has a Boolean type, and we'll discuss that later on. The other type that Java clearly has is this, or the other operation. Here you go, 365 mod 7. The reason Christmas creeps ahead a day of the week each year, right? And you'll see that that's going to be 1. Okay. Oops. I need to get rid of that period. And you can see that's going to be 1. So all the same operations are present for the 4 integer types that are present in Python's numeric types. So that's the 4 primitive integer types that are present in Java. Next time we'll discuss 4 other primitive types, 2 of which are floating point, and then 2 of others that are sort of off by themselves. One is Boolean, and there are important differences between Java's Boolean and Python's Boolean. And then there is also a single character type that enjoys a certain amount of fluidity with integers. But we'll discuss those things next time.